Hello, everyone. Sorry for having to move the office hours around. Let me just see if it's okay. Okay, so we are at week 6 office hours. I had to move them from Monday, so this is not our standard time. I pushed it up by a few minutes just because I wanted to make sure that I give people a chance to see the link for the office hours. I'm sorry, between all the travel and all of the a preschooler at home and the weather not being sure whether it should be spring or winter, kind of have had back-to-back calls, and it just made no sense to try to have office hours with sneezing and coughing, much more so than normal. So I moved them. Thanks for being flexible. So let's see, there are few people online. I'm hoping that that you guys can hear me, and if not, I will expect that you'll raise a flag. So did I not put the office hours link in there? Why am I not seeing the week 6 office hours link? Just, okay, there it is. It's there. Okay, here it is. And let me just pin it so people can find it. All right. So a few people are online. I guess if you cannot hear me, write something. If not, I'll just keep talking. So we got project in. We gave a little bit of an extension just to kind of accommodate last minute, people trying to go for a last minute push. We're not going to, by default, give you an extensions. We try typically to be a little bit flexible and to just give you a little bit of extra time. With the first assignments, we realized that typically a lot of things start coming together really toward the end. It's not that you're not trying, that you don't start trying early enough, and it's just kind of the nature of this process. So hopefully that helped. We are going to, several of you ask some questions about the submissions, whether they're in. We are going to pull the submissions basically from Bonnie, and we're going to grade your last submission. I know that some of you, just in case, ended up adding something in T-square. If by any chance, you sort of feel that there's some discrepancy between whatever went in T-square and Bonnie, just put a private README so we can pay attention to that. But I don't expect that to be the common case. So the grading of Project 1 is, you've been getting some feedback from Bonnie, so we explained already. A big part of it relies on, or actually at least the first pass of the grading process relies on the tools, on the auto grading tools. You guys don't see the points that it returns. The TAs, they get much more information, both in terms of points and kind of where any problems are. Typically, statistically, what we end up seeing is that if you end up passing the auto grading test, that at least in terms of the points that are coming from those tests that are run through the auto grader, typically there aren't any problems. But we still go in and manually look at some of this, look at certain portions of the submitted code to make sure that things are properly implemented. And then in particular, whenever there are things for which you are not passing some of the tests, that's when we try to really go in and understand what's going on, so as to be able to give you as much partial credit as possible. So there is a kind of a coarse grain distribution of the points that you can see as part of the assignment, as part of the posted assignment. The the finer grain tests that we're looking at ultimately end up contributing each test to 2, 3, small number of points, and they were intentionally designed like that. And Tony took deserves a lot of credit for that. So they were intentionally designed in such a way so that we test at as fine granularity as possible certain pieces of your submission, so that we can give you as many points as possible. So with that, despite all of the auto grading and everything, it does take some time to go through the first assignment. I should add that we do have an additional TA that has joined the TA team just this week, actually just in time for grading project 1. So welcome, Daniel. So what we end up doing is divide the TAs, divide the assignments, and then everyone takes a lead of grading a portion of the assignments. At some point toward the end, there is a work stealing algorithm that gets put in place. So if any of the TAs, because they're just like you, they have their own jobs and deadlines and everything. So every now and then there are reasons why one of the TAs is falling behind on the grading of their original assigned list. So the other TAs pitch in, and so we try to do it as efficiently as possible. It will still take us order of a couple of weeks. You will receive the grades for project 1 definitely before the deadline. However, we cannot. At this point, right now I cannot really give you a better estimate of when you'll receive the grades. When we talk next week again, by then probably the TA would have sort of looked at the initial assignment and how many tests every one of them is looking at, how many submissions every one of them is looking at, and so we'll have a better estimate. Just so that to kind of couple of things in terms of the grades. When the grades are returned, the grades will be returned through T-Square, and you will be able to see a feedback. You will be able to see a feedback field there, and you will have some information about, for instance, if you didn't get full credit or if you didn't get as many points as you expected, you will be able to see something about where the points were lost. If there are any reasons why that's not clear to you and you have any questions, the protocol is that you put up a private post asking for explanation, and just make it visible to all of the instructors. Whoever is the instructor that has graded your assignment, in this case, all of our instructors are he will end up getting back to you within some reasonable amount of time. Yeah, actually, this semester, all of our TAs are men. We've had in the past, I think we've had some semesters where we've had more than half of the TA team. There was one semester that more than half of the TA team were female. But so girls, think about volunteering. It's a very rewarding task, and I do feel that you end up also learning in the process. I certainly feel that every time I'm teaching a class, doesn't matter how many times I've taught it, I end up learning something in the process as well. So consider that. And I think I've mentioned before, it's not that any of us on the faculty side that we end up favoring in some way those students that end up being TAs. It's just because they end up being a little bit more exposed to the topic and they typically end up with some more interesting opportunities in terms of internships or those sorts of things in the future. We've had several of the TAs that have, just in the program in general, that have ultimately converted to full-time graduate students pursuing their PhDs. So, so hopefully there are more of you like that out there. So that's as far as project 1 goes. The second general update regarding the course I should put out is that we did distribute, we did put your the class list, the class roster to over to ProctorTrack. So you should have received at this point an email to do the onboarding test. I mentioned this before, the onboarding test is really to make sure that you have the right login credentials and to make sure that kind of in general you're familiar with what you need to do to start your exam, the proctoring experience, but most importantly, the onboarding exam, the onboarding test, I should say, is there to test the compatibility of the machine that you're using with the requirements for the kind of the backend that's doing the monitoring and the analysis, and the proctoring client that's running on your machine. So make sure that you do the proctoring test on the machine that you're using, that you are planning to use to take the tests, the midterm and the final exam. One of the things that you should consider is that most of the issues come up regarding some of the peripherals. So there are complaints about double monitors. There's some compatibility that sometimes comes up with certain types of microphones, for instance. I guess Patrick put a message that from his experience, he's had some issues where the only way that his microphone was detected was through yelling. The microphone isn't something that we rely on during the test. So you will have a written test that you need to type in or your answers or do select the appropriate choice. But it's part of the requirements of and I think there's a step when you're initially introducing yourself that requires. I actually haven't taken an actual test, so I'm not sure what the proctoring steps are. When I did do it, our class was the first class that switched to this ProctorTrack service. We used a different service before, so ProctorTrack has evolved some of its interfaces quite a bit from when Georgia Tech started using it for the OMS program. And so whatever I took, I know that it's already significantly different than what you guys are seeing today. So I haven't done the exact same proctoring test as you have. So make sure that you give yourselves enough time. So don't plan on I'll just run the proctoring service, the proctoring test the day when I'm planning to take the midterm, and then I'll switch into the midterm. It's not frequent, but every now and then there have been students that have run into some sort of issue and that they had to resolve first before they can actually take the test. So make sure you do that. We did push the message regarding the proctoring to everybody via email. The odds are, if you're going to be watching this office hour, that you're already on Piazza and your email is correctly configured. So, I'm not sure how much sense it. Okay, I should turn my email off because it's just going to keep beeping. So I'm not sure how much sense it makes sense, but if there is I guess if there is a separate channel, that I know that there is a separate channel, I just try to stay off of it just because I consider that that's your private channel that you guys communicate amongst each other. Just make sure that somebody puts a note and reminds everybody else to take the proctoring on the ProctorTrack onboarding test. If you've taken a class through the OMS program before, you should be fine. I don't think that there've been it's the same service. So another update regarding the exam is there is a as part of the lessons that you see in Udacity, there is one link that hosts some set of questions that are labeled as sample midterm questions. I took most of those questions, not all of them, but most of those questions, and I also converted them into a sample midterm exam questions in T-square. The intent of that is for you to be able to see what an exam in T-square could look like. So if you'll have to log in, you'll have a certain interface, how you move through the questions. And so first, it's just to see what the look and feel of a T-square hosted exam, just to eliminate that part of the surprise element. And then the second intent of those questions is to see, to get a kind of a look and feel for the kinds of questions, the format of the questions that we can ask, and the level of depth, the detail that we may be asking for. So in the quizzes, in the questions that are sprinkled throughout the lessons, there are a lot of questions that require you to go kind of on a Google hunt, where or to look at source code, or to maybe even write snippets of code. One of the sample questions that's currently in Udacity is also asking you to write some pseudocode. Those types of questions are really not friendly to T-square, and definitely not friendly to being graded in some sort of scalable way. So with these classes, with a few hundred people, we ended up structuring the exam slightly differently. There's also a philosophical difference, so for me to ask you a question that requires you to really memorize something and memorize what a API looks like, that serves no purpose in real world settings. As long as you conceptually know what you need to be doing or how things work, you'll always be able to Google and find the details. So the questions will be testing mostly your understandings. As long as you kind of understand how the OS works, what are the main components, what does it mean that there's a mechanism versus a policy, how does the life cycle of a process work, what are the core components of an operating system, what is the purpose of the thread abstraction, what's required to support threads at the kernel level versus at the user level, how did we evolve to this world today where the default way in which we use threads, well, p-threads, which are the de facto standard, is that there is a kernel level thread for a user level thread. What are the common ways to structure applications with threads? So these types of questions are things that you can expect, that you should, just from being able to understand the lessons, you should be able to provide answers for these questions. There will be some questions that will require you to maybe think through a kind of a calculation. So we will allow calculators for the test, and we will allow scratch paper. We will allow kind of paper and pencil for the exam. We'll remind you of this again next week as we near the exam. But the idea is that you show the paper front and back in the camera, and then you can use that paper if you need to work out details of a question or a computation. You may use a calculator, a physical calculator, kind of the old-fashioned calculators. You may use the calculator that's the calculator application that's in your computer. You will not be allowed to use a cell phone. For the notes part, also, it's okay to use a simple editing tool like Emacs or kind of Notepad or whatever, but you cannot use, again, no other devices other than a calculator will be allowed. And the test will be closed notes, closed book, closed internet. You will have an hour and 20 minutes for it and about 10 questions. So that's regarding the test. The test will open, let me just double check. The test will open, I think I said it to open on Friday. Sometimes I said to open on Thursday. So let me just double check to make sure I don't give you the wrong official. Whoopsie, sorry. I clicked on the wrong one. Not that email. So 23rd is Thursday. So we'll open the test at 3 p.m. on Thursday. You will have through the whole weekend to work on the test, and the test will close Monday. We'll actually close the test kind of Monday midnight anywhere on earth. So you'll have all of Monday night to work on the test. Part of that requirement is and to avoid some of the potential disaster where everybody just starts rushing to submit it at midnight. Like, this, if we give you the whole night to work on it, can spread things out when submissions are coming in. So you'll have until midnight on the 27th anywhere on earth. So that pushes things, at least for some of you, until the early morning hours on the following morning. We always try to give all of the tests, to open all of the tests in such a way that, whatever works for you, whether it's easier for you to take it during a work day, school night, weekend night. Some of you have kids, family members that you need to coordinate with. So doing something on a weekend is actually harder, or finding a couple of hours to sit in a quiet place on a weekend is harder than doing that during the work time. So we're trying to be flexible. So hopefully this provides everyone with enough opportunities to decide on what's a good time to take the exam. And we will send you a reminder next week again, but a couple of things. Make sure that you save the answers as much as possible in case there's some kind of disconnect. And then the other thing that I should say right now is during the actual exam period, so while the exam is open, if you've taken the test, please do not discuss the answers on Piazza. This should be sort of an obvious thing, but let me just say it. And do not and wait for us to give you green light on when it will be okay for you to discuss the questions. Just because every now and then there is some last minute emergency that somebody runs into, and then we get a request from the Dean of Students to accommodate an extension for somebody. And so it's possible that although the official exam window has closed, that there's still somebody who has not completed the assignment. So just make sure that you do not discuss it, whether it's on Piazza or any of the other channel, Google Groups, Slack, or whatever else, that you're not discussing the questions of the exam or the nature of the exam. Okay. So see, that's my Valentine's present that from my now 5-year-old daughter. She turned 5 10 days ago. Okay, so basic info on the test, basic info on project 1, project 2. So project 2, I will open that up tomorrow. We'll push that out. We'll push a reminder out to everybody just so that you know that project 2 is open. We will keep the project open through basically the weekend after the midterm, just to give you guys time to figure out whether you want to work on it before the midterm, or if you're studying now for the midterm, given that you've probably been working on project 1 until just a couple of days ago. to give you a chance to, if the weekends are the primary time that you have for these courses, to give you at least one free weekend where you can focus on the project, on the midterm, and then to have that following week and the weekend days to work on the assignment. Now, the thing that I should say is that so project 2 is not really a programming project. It's going to be just a quiz. And it's going to be a quiz that's related to the last lesson in part 2. It's going to be a quiz related to P2L5. So you'll have a bunch of questions that you'll need to answer. And these questions, so the point is that because it is this assignment is going to be related to the material from part 2, although the assignment itself is not going to be due until after the midterm, we do encourage you at least to spend time kind of going through the questions, thinking about the questions, and that will really give you a little bit of a chance to do some little extra prep work for the midterm. So we'll kind of force you at least to spend time on that P2L5 module of the midterm. The quiz itself will really not take much time to do. So it will be some less than 10 questions quiz that are directly the point of the quiz is going to be to get you to really think about experimental evaluation, and to get you to think about what are some of the performance trade-offs when it comes to multi-threading. So when is multi-threading good? When is it bad? When would one expect to see benefits versus not? And then, so that's kind of one set of questions will be along those lines, and then a second set of questions will be around how would you structure an experiment? So what would be some good things to measure, etc. The motivation behind this assignment is we really don't have the right kind of infrastructure to guarantee that every single one of you will be able to perform detailed, meaningful performance evaluations of the projects that you develop. So from a systems perspective, just building a system for the sake of saying, okay, it works, without really understanding, well, does it work well? Does it, work better than some other system? Or, okay, it works, but am I going to have to throw in a whole bunch of resources? Am I going to have to upgrade my servers? Am I going to hit some bottlenecks? Am I going to, okay, it works, my system, but is it really going to be able to support the workload that I'm trying to host? In order for true systems work, you really can't just build something and just code something and say, yes, it works, without really doing the experimental evaluation part. And the papers that we have, some of the research papers that will look at in this course, there's always some sort of graph that's showing you something, some how does the system perform, or how does it scale, or what are some bottlenecks, or what's the difference between a couple of approaches. So performing experimental analysis and experimental evaluation is very, very important. It's crucial. Even researchers that do more of an analytical, more of a theoretical system work, even they'll put some graphs forward to kind of illustrate some of the trends that their analytical model predicts or is kind of intended to support versus some other work. So if this weren't an online class with many of you all over the world that are sharing the access to Bonnie, so if this weren't an online class, what we do is we would make sure that we provide you with access to some number of resources, some number of virtual machines where you can run your experiment, but not just a virtual machine. So it would have to be an environment where you can run whatever you've built. So in this particular case, project one, your server, right? That's kind of the core of your contribution. The client is just the workload generator. The server is the core piece of the system that you've built. So we would have provided you with an environment where you can run that server in an isolated way. So it's just the server that's running the machine. You really know what the machine looks like, because on a different type of hardware, if it has more memory or less memory or more cache or more CPUs, things would behave differently. So you need to understand the hardware. You need to know that you're running alone and not with a whole bunch of other students testing their submissions. And then that, when you're generating the workload, whatever is going on that machine is really just in response of to the request that you're sending. And then you collect from there some performance data. And so, ideally, every single one of you would have been able to do something like that, which is there is a cost to that infrastructure. I mean, I know we could potentially go and rent dedicated instances, Amazon EC2 instances, and give every one of you a slot when you're going to run something, but that's either going to be too expensive if we're going to do that in a way that provides you with flexibility, or it's going to create a nightmare on your end, your ability to just really find the right slot in coordination to find the right slot to have access to perform those results. So that's one part of the reason why we're not asking you to perform experimental analysis as part of project one. The fact that in order for those experiments, for us to guarantee that you can do meaningful experiments, we have to make sure that we can give you designated and isolated resources, and we can't do that. And then the other part is because for us to really test your how well you're able to design experiments, we need to provide you with enough flexibility that then on the evaluation side, on the grading side, on the assessment side, will make things too difficult for us. In fact, during the first semester, we gave quite a bit of flexibility to the students. We still restricted things in some way, but we gave the students quite a bit of flexibility. And I mean, it took a month to grade that assignment, and we had a team of 8 or 9 TAs. It just took forever. So that's just the amount of effort that the TAs spent on grading that assignment. They really need to spend that on helping you guys when you're stuck, keeping an eye on Piazza, keeping an eye on kicking the backends or whatever else needs to be kicked in case there's some problems. There are always some problems with software. I mean, there many billion-dollar companies that put software out there that has bugs. So excuse us if there are problems that are coming up in some of the software that we put out there for you to use. But we do have great TAs that are able to put out fires as soon as they whenever something like that comes up. So because of that, we're not asking you to perform the design of your experiments by yourself, but we are giving you. So instead, we'll give you a quiz so that's going to be that project 2. So we'll give you a set of questions that you can answer. And in these set of questions, essentially, in order to answer these questions correctly, you'll really need to understand, or you need to think through some of the process of, well, how would you design an experiment if you ran a particular type of experiment with the server that you developed in this assignment, and then a particular workload that has particular types of characteristics in terms of what kinds of files that it's asking for, how many, how do they differ, etc. That you'd be able to tell us what do you expect. So do you expect that as you add threads, the performance will increase, or do you expect that as you add threads, the performance will decrease? Or maybe we'll ask, well, you have two not maybe, but some of the questions will be, say you have two identical configurations of the same multi-threaded server with the same number of threads, but if one is dealing with files of smaller size versus file of larger size, or one is running on a machine that has more memory versus less memory, or more CPUs versus less CPUs. So you'll need to really think through, okay, what could be happening? And your number one resource for answering these questions is going to be what's covered in lesson P2L5, and really the accompanying paper. That's the paper on the Flash web server. So really thinking through that paper and looking at all of the things that paper raises as, this is what happens for the multi-threaded. So the paper proposes a event-based design of a server, and then it compares that event-based server design to a multi-threaded, to a number of other configurations. Among them is a multi-threaded configuration, and the multi-thread configuration is essentially what you've been developing. So that's what you'll have to think through, the same kinds of questions as similar kinds of questions that come up in that paper. So the recommendation is that we'll put the assignment out. You should you can read through it, but if you're kind of not really sure what possible answer you should be giving is at that point, just find the time to go through P2L5. You'll have to go through it anyways before the midterm, just because it's going to be on the midterm. Read the paper, the Flash paper, and then come back to the assignment. And I'm sure that at that point, you'll have a much better idea of what are the right set of answers. So aside from going through that lesson, P2L5, actually, once you've gone through that and once you've understood that lesson, then the actual assignment should not take you much time. And the assignment, I will post it. The assignment will also, just FYI, the assignment will appear under testing quizzes. So I'll put the announcement out, and I'll add this clarification there, but you will need to go into testing quizzes. That's the same place where the current sample questions are posted, for the sample midterm questions are posted, and that's the same place where you ultimately will have to go. That's where your midterm will appear, under the testing quizzes. So we will come back a little bit more and talk a little bit more about the programming, the project 2, not the programming assignment, but project 2. Once next week, once we've put it out and you've had a chance to look at it again, you'll have a couple of weeks to complete that. We're assuming we'll focus on the midterm first, and maybe then you'll wrap that up. But make sure that you take a look at it and think about it even before the midterm, just because it corresponds to material that's part of the midterm. Okay. So there is a question in Piazza that's asking again on contrasting P threads compared to user level threads and kernel level threads. The Solaris papers that that are discussed as part of P2L4, they describe two different things. They describe the threading model in the Solaris kernel. So back from 1995, right? And they describe a user-level threading library. So this really evolved into ultimately what became the the pthreads API. So pthreads is the de facto, the standard, the POSIX threading model. So it's the standard model for user level threads in the Unix-like systems. Though there is also pthreads that's available for Windows. And the pthreads are a little bit different than the native than the Windows native threading model, but in terms of other Unix systems, so pthreads is a pretty standard API. So it specifies not just the actual API, but also the semantics of some of the operations. So, for instance, not just that pthreads wait should have a particular syntax in terms of the condition variable and the mutex with the order that they need to appear, etc., but also the semantics, and the semantics that's part of pthreads actually matches the wait semantic that was specified in the Burrell paper. The syntax doesn't match, but the semantics does match. So in the sense that wait will atomically, if it will so it will release the mutex and put the thread on a wait queue for that condition variable. So the releasing of the mutex happens so that somebody else could potentially come in, get the mutex, change the state that ultimately implies whether or not a particular condition variable should be signaled or broadcast. And so when a thread comes into a wait, actually while it's waiting, the thread does not own the mutex. So somebody else could get the mutex and do the right things. But that when you actually come out of the wait, at that point, you have the mutex that was released, so the mutex that's specified as part of the wait API. So this is different than the wait semantics in other threading packages, but when it comes to pthreads, this is what it looks like. Now pthreads, it's really a user level library. However, I think we talked a little bit about this in the past, is that when it comes in Linux, over time, for a number of reasons, and the reasons that have to do both with the physical resources that are available on modern hardware, and also reasons that have to do with we've gone through, we've revised a lot of ways how we implement certain data structures, how we implement certain mechanisms. So it's become possible at the kernel level to actually support many kernel level threads. So we can support many kernel level threads today at the OS level. And two, we've also, as a combination of both software advances as well as hardware support, we've made it relatively cheaper to perform crossings between user level and kernel level. It's not free, but it's cheaper. So because of these two things, so it's one of the reasons why we wanted to have separate user level threads and then separate kernel level threads, was so that the kernel can focus on kind of managing few things well, but then at the user level, potentially we can have much higher degree of parallelism, because we could spawn as many user level threads as possible, and that the interactions between them will be cheap because they can just deal with interactions in user level. They will not have to maybe like synchronize or anything by going into the kernel level. Now, if that operation, if that, given, not if, but given that the user kernel level crossing has become cheaper, and given that at the kernel level we can support higher number of threads, so that's already on its own kind of provided, keep my session alive, T-Square wanted to close on me. So that's already provided an environment what becomes possible or much more practical to have a model where it's a one-on-one model, where we have a user level thread that's mapped to a kernel level thread. So now, the user level P threads are really mapped to a kernel level thread. So on one end, that's become more practical. On the other end, if you if you've gone through P2L4, there are quite a bit of pieces in P2L4 when we discuss the Solaris papers, where I describe some pretty contrived ways on how the kernel and the user level thread management, the user level library, have to interact so that a signal that's the kernel needs to pass to the multi-thread application ultimately gets passed to the correct user level thread, or so that a signal ultimately gets passed to a user level thread that has the signal mask such that it's capable of handling that signal, or reasons. Some of the reasons for some of the complications were the fact that now the kernel level schedules and preempts and context switch the kernel level threads, and that may be kind of a completely wrong set of decisions for what's happening at the user level. We'll have a thread that locks a mutex, and then the kernel level will context switch that. So the fact that there are some challenges in how the kernel and the kernel and then the user level threading library have to interact in order to deal with both these issues of signaling and to go around certain problems that have to do with concurrency and synchronization and scheduling, because that was complicated. And then at the same time, it became so that was complicated in a many end-to-end model where we have M user level threads and a different number of kernel level threads, and so that was complicated. And then on the other end, having a one-to-one model where we have kernel level thread for every user level thread, that became kind of more practical. So it's not free, but it is relatively cheaper. So because of those reasons, we've gone now in a direction where the model that's supported is basically for each of the, in Linux, for each of the user level P threads, there is actually a kernel level thread. So it's a one-to-one model. So, it's a user level, it's supposed to be a user level concept P threads, but there is actually, when you're working with P threads in Linux, there is a kernel level thread that's associated with it. Now, today, we're hitting a point where our hardware actually has a level of concurrency that's an order of magnitude and then some compared to the time when we perhaps made this decision that this is the right thing that we need to support, this one-to-one model. And we're also running into applications that have at the application level extremely high degrees of fine-grained concurrency. So there are more and more user-level runtimes that support really high degree of concurrency. Not like lots of P threads concurrency, but like fine-grained tasks and those sorts of things. And so for those kinds of frameworks, I mean, this originally started happening more in the high performance community, but now it's spreading out in other ways. So for those kinds of environments, for those kinds of applications, so basically we're coming to a point where we do have application classes that require a really fine-grained level of concurrency that now for them, it's becoming, again, a little bit expensive to have a one-to-one model. And so there are a number of not just research projects, but especially in the HPC side, solutions that are in practical use, where we are reverting back to an end-to-end model, where at the user level we have, so that's not for pthreads, but where at the user level we have something that has lots and lots of tasks, or lots of lightweight threads, and then a much smaller number of kernel level schedulable entities of kernel level threads. So some of the lessons that we learned from the Solaris paper, so why do we study this n by n thing and all of these problems with the n by n model if what we have today is anyways one-to-one mapping between the user level to kernel level? So all of those n by n type of problems that were there when we started multi-threading the kernel and the applications are actually coming back in some form and need to be revisited in present day and becoming relevant in present day. So that was a very long answer to your question, but hopefully that helps. One of the things that I do want to mention briefly is when you're reading the Flash paper, so the Flash paper describes a different way of providing concurrency in application that's based on events and event handling as opposed to threads. If we have many CPUs, then certainly we want to run multiple such event handlers like what's described in that paper. But as a model, so there is a very popular kind of a server framework out there, Nginx, that's used for many commercial web services, and it's really high performance. That and provides for very low latency. And that's built around an event model that's very much like was described in the Flash paper. So, for instance, if the Apache web server is more like the boss worker, not identical, right? But like the boss worker model the threading model that you've developed in your project one, this Nginx is more like what's described in the Flash paper in P2L5. And just FYI. Hoban posted a question that he found somewhere. I don't know, Hoban, where you found these questions, but I'll answer it. So there's a question of when are the following assignments going to be open? As I said, we'll post P2 tomorrow, and that's going to be a quiz with a set of questions. I should remind you that as a quiz, P2, it's not going to be timed, so you're going to have infinite amount of time to take it. You can take it any time between now and the deadline, and whatever ends up being your last set of answers in T-squared, that's going to be the one that we will grade. We will open P3 immediately after the midterm is over, so there will be kind of an overlap between when P3 is open and officially open, and before P2 ends up being due. So in terms of when you can start thinking about P3, you'll have plenty of time, and it will be, as I said, after the midterm, we'll open up P3. Okay, so the following question, Hoban already answered. Hoban, where did you find all these questions? Am I looking at the wrong place, or what's going on? So for the P2 assignment, which is going to be administered as a test, you'll have infinite number of attempts, but for the midterm, you will only have one chance. and we'll talk more about midterm or any type of gotchas that you need to be prepared for next week. Amit, so the midterm, I put in some sample questions so that you can get some idea of what type of questions we will ask on the exam. So there'll be a combination of fill-in blanks, multiple choice, and maybe some short essay questions that you'll have to answer, and it will be computer-based. It will be administered via T-Square. You've probably joined the office hours at some midpoint. If you want to go back, just so that I don't repeat, if you want to go back to the earlier part in the office hours, right after I'm done talking about Project 1, actually spend a little bit of time talking about the midterm, and we'll talk more about the midterm next week as well. And this next question, are there any studies so it's a good question. So Dan is asking for kind of a concrete paper that would show some of the, or a concrete study that would illustrate some of the trade-offs between the one-to-one model that Linux has now versus the N-by-N model with the lightweight processes that's as described in Solaris. I cannot, right now, I cannot give you a good reference. I do know that many such papers did exist. I'm just kind of completely blanking out on some paper that would actually, in a more systematic way, quantify some of those trade-offs and quantify what really is causing, what really has caused the shift, that some of the costs that we wanted to avoid in the first place when we introduced when we adopted the N-by-N model ended up disappearing. I mean, it's not just that we made the kernel crossing cheaper. There are a number of other things that have changed, including what do the kernel level data structures look like? How do we represent the process? How do we represent the kernel level thread? How do we represent the various pieces of information that are necessary to describe an execution context? And so it becomes also, the kernel level becomes cheaper to perform certain operations, having separate stacks. So there are a number of things. So it's not like we can take the Solaris from then and the Linux from now and then do a comparison and say, oh, well, this is how much things cost with a one-by-one model in terms of impact on performance or impact on like system level overheads in terms of memory that's how used for threads structures or anything like that, versus in the Solaris paper. There are enough differences that just doing a direct comparison between the two, it's not feasible. But as we've been moving to this model, there were studies that had performance data. I'm trying to remember whether some of the original papers that describe the Linux threads versus the native threads in Linux, whether any of those papers had any actual performance data that motivated this. So let me just quickly pull up some of the papers and your original. So they would probably have some of those things. So I'll take a look and I'll post if there is anything that has some of the performance data. I'm now blanking out on where would some of the performance comparisons have appeared. Though I do know that this was not motivated based on just some random observations, but it was actually motivated by on real data. Yes, I mean there are already. So if you look at kind of the original description of the current model, the native POSIX thread library for Linux, there are some data points on thread creation, thread exit. So there are some performance charts with the Linux threads versus the current model, and there are some benchmarks. So maybe not as detailed as I'm sure there are some other sources. So I'll post some. Okay. Okay. All right. So let me see if there's a quick answer now. Okay, so that's about it as far as questions go. So I'm going to wrap up, and then we'll see you guys next week. Okay. All right. Bye bye.